Now next, that is example 6.8. A metal bar 70 centimeter long and 4 kilogram in mass, supported on two knife edges, placed 10 centimeter from each end. A 6 kilogram weight is suspended at 30 centimeter from one end. Find the reactions at the knife edges. Assume the bar to be of uniform cross section and homogeneous. So now first try to understand this entire given situation with the help of figure. See here the figure. We have this AB metal bar, which one is 70 centimeter long, and it is 4 kilogram in mass. So its weight, that will be from its midpoint at point G, we represent its weight W, right? Now here from the midpoint or center of mass, each end, that will be at 35 centimeter, because total length is 70 centimeter. Now knife edges are placed 10 centimeter from each end. So from A at 10 centimeter, knife edge is K1. From B at 10 centimeter, knife edge, that is K2. So when rod is placed on this knife edges, so at this particular knife edges, we will get the reaction. The normal reaction will be R1 and R2. Now here it is given to you, a 6 kilogram weight is suspended at 30 centimeter from one end. So from this end, suppose at 30 centimeter, mass 6 kilogram is suspended, so its weight, that is represented here W1. So that will be at 5 centimeter from the midpoint. Easily we can understand from the figure. Now we want to find these reactions at the knife edges. The system, the rod, that is in mechanical equilibrium. Okay. Now here say all this data that is given, and we already discussed from the figure. AB, that is 70 centimeter, AG 35 centimeter, AP 30 centimeter, PG 5 centimeter, AK1 equal to BK2, that is 10 centimeter, and K1G equal to K2G, that is equal to 25 centimeter. Okay. Now see here, weight of the rod itself. So mass of the rod is 4 kilogram. So 4 into G, so 4 into 9.8, that is 39.2 Newton. And W1, the suspended weight at point P, 6 kilogram into G, that much Newton. So that is 6 into 9.8, that is 58.8 Newton. Now R1 and R2 are the normal reactions at the support at knife edges. Okay. Now first consider the translational equilibrium. So for translational equilibrium, net force acting on the rod, that will be equal to 0. Total how many forces are acting? So two reactions, R1, R2. One, weight of rod itself. Second one, the weight W1 suspended at point P. Total 4 forces are there. Two reactions are in upward direction, which will be considered positive, and W and W1 are downward, will be considered negative. So net force, that is R1 plus R2 minus W1 minus W, that is 0. Substitute here values of W1 and W. So we can write R1 plus R2, that is 98. Say this is equation number 1. Now consider the rotational equilibrium. So for rotational equilibrium, the net torque acting on the rod, that is 0. Now torque will not be produced by all these 4 forces. Why? Here this W that is from the center of mass, that is the reference point. So when the force itself is at reference point, it will not produce the torque. So remaining three forces will produce the torque. Torque, that is force into perpendicular distance from the reference point. So reference point is G here. So we can write now for rotational equilibrium R1 into K1G, that is the torque due to R1. Now here anti-clockwise torque are taken positive and clockwise are taken negative. So this one is negative. Then W1 into PG, that is the torque due to W1, that is anti-clockwise, so it is positive, plus R2 into K2G, anti-clockwise, that is positive and that is equal to 0. Now K1G 25 centimeter, so that is 0.25 meter, PG that is 5 centimeter, so 0.05 meter, G that is 0.25 meter, and W1 that is 58.8. Now if we solve this one, then we will get here R1 minus R2, that is 11.76 Newton. Say this is equation number 2. Now here with the help of elimination method, suppose first we take the summation of these two equations, then after take subtraction of these two equations. So in this way, by elimination method, if we solve these two equations, then we will get the value of R1, that is 54.88 Newton, that is nearly equal to 55 Newton, and R2 that is equal to 43.12 Newton, which is nearly equal to, we can write 43 Newton. So in this way we can calculate the reactions at the support are about 55 Newton at K1 and 43 Newton at K2. Clear to all of you?